Welcome everyone, this is Miss Orsi with a deep voice because of my cold, sorry about that. We're going to hopefully make this a quick one. This is just dealing with ordered pairs and the coordinate plane, and the learning target is to know features of the rectangular coordinate plane, being able to plot an ordered pair, being able to identify the position of a given point as an ordered pair, and then being able to identify the position by the quadrant or axis that it lies in or on. Okay, so let's just first kind of get to the idea of the rectangular coordinate plane. Down below we've got an example of the rectangular coordinate plane, which I'm sure that you've seen before. Okay, a coordinate plane is made up of two, what we say perpendicular, oops, I want a different color, two perpendicular number lines. And this is a pretty fancy word that we're using here, perpendicular. You might have heard that in some other classes before, but we're looking at two perpendicular number lines. And the idea of being perpendicular means that when they intersect or cross, they make 90-degree angles. Or sometimes also called a right angle. Okay, so two perpendicular number lines. In chapter 3, we were using a number line to graph inequalities with the open dots, solid dots, shading, and now we're going to look at two perpendicular number lines. One of them will be horizontal. So we will have a horizontal number line, just like we did in chapter 3. Okay. And horizontal number lines, when we think about the word horizontal, or if you look at the root word in there, the horizon, the horizontal number line is the one that goes side to side. We call that the x-axis. Okay. Horizontal number line goes side to side. That's what we were considering in chapter 3. Going side to side is called the x-axis. And the vertical number line, and vertical goes up and down. The vertical number line goes up and down, is called the y-axis. Okay, so we've got the horizontal, which is the x-axis, and the vertical, which is the y-axis. Down below, I'm just going to label those. This is the y-axis, and this is the x-axis. Down here, I can label those two things together. Okay? All right, every point on the grid, not just the ones that are on the grid marks, but every point in here can be labeled as what we call an ordered pair. Now this has two components here. First of all, obviously pair means that there are two things, and ordered means that we have to put them in a special order so that we know what's what. And the order that these come in is that x is always first and y is always second. The x value comes first, the value on the horizontal number line comes first, and the y value comes second. Okay, it's alphabetical, it's not difficult to remember that. Okay, and then so the first value in the ordered pair, the x value has another kind of special name for it. So the first value in the ordered pair is what we call the x coordinate. You might have heard the word coordinates before, like in maps, talking about x or y coordinates, but we call that the x coordinate. And then the second value in the ordered pair is the y coordinate. Oops, not y value, we're going to call it the y coordinate. Okay, tells us where we are in the y direction or in the vertical direction. The x coordinate tells us where we are in the horizontal direction. Ordered pairs or points, when we label them on the rectangular coordinate plane, we use capital letters to label an individual point. Capital letters. Okay. The x and y axis if you look at where they meet, where they intersect, and I wish that there was a little bit darker here to see where that was, didn't come out very well, but the x and y axis meet at the point, or with coordinates 0, 0. Right there, x and y axis, this point right there is the point 0, 0. And it's where basically sort of the middle of the x-axis is and the middle of the y-axis. And because that's where we would start counting, either to the right, to the left, up, or down, it's the beginning of our counting, so we call it the origin. Okay, another word for origin is kind of the beginning. Sometimes you'll see the origin denoted with the letter O, because it's kind of the 0, 0, and obviously the O for origin. Okay. Next, the x and the y-axis break the coordinate plane into, so if we look at the x and the y-axis, we're breaking that coordinate plane into 4 different regions, which we call quadrants, into 4 quadrants. And that root word quad means 4. Okay. And so in the, if I look at where these cross, right here, there's the origin. To the right, I would have positive x's, and then up, I would have positive x's. This is where we have the first quadrant, and we call that quadrant 1, but we always label the quadrants using Roman numerals. Okay? And then we rotate counterclockwise when we're labeling those quadrants, counterclockwise. So this is quadrant 1 in the upper right. And then rotating counterclockwise, the opposite of the way clock goes, this would be quadrant 2. Roman numeral 2 looks like 2 eyes stuck together. And then counterclockwise, down here, this would be quadrant 3, which looks like 3 eyes stuck together. And then finally, this is quadrant 4. Okay? And as I said before, and quadrant 4 is an I and a V, because in Roman numerals, V means 5, and so this just means basically 1 before 5, if you remember that from previous classes. Okay, and as I was saying before, we start with quadrant 1 in the upper right, because this is where we have all positive x's and positive y's. So going in kind of the natural direction. Okay. And then quadrant 2, now we're moving to the left, so it's negative x's, but still positive y's. It kind of looks like somebody's winking at you. Down in quadrant 3, this is the opposite of quadrant 1, so that's where we've got both negative x's and negative y's. Looks like somebody's sleeping. Get emoticon for somebody sleeping. And then down in quadrant 4, we're to the right, so we've got positive x's, but we've got negative y values because it's below the x-axis there. Okay. So when we start finding points that lie in each quadrant, I'm just going to kind of pick some points and give an example. If it lies in quadrant 1, we need a positive x and a positive y. So for example, I'm going to plot the point 3, 4. That's in quadrant 1. So from the origin, I would go to the right, 1, 2, 3, and then up 1, 2, 3, 4. And that is the point 3, 4. I'm going to label that, let's label that with the capital letter A, to say that that is point A. In quadrant 2, okay, so now I need a negative x and a positive y. So a negative x would be like negative 5, and a positive y would be like positive 7. So if I wanted to label the point, or plot the point negative 5, 7, here's negative 5, 1, 2, 3, 4, 5, to the left 5, but then go up 7. 1, 2, 3, 4, 5, 6, 7. And I'll call that point B, capital letter B. So that's the point B. Something in quadrant 3, I need both negative values. So let's say negative 4, negative 1. So from the origin, go to the left, 1, 2, 3, 4, and then down 1. We'll call that point C. Okay. And then finally in the fourth quadrant, we need a positive x but a negative y. So let's say positive 2 and then negative 8. So positive 2 would go from the origin to the right 2 and then down 1, 2, 3, 4, 5, 6, 7, 8. Notice I'm always doing the x coordinate first and then the y coordinate. Let's conveniently call this point D. All right. And then we've got points that lie on the axes. So if I have the x-axis and I want it to be on the x-axis, That means that I have to move either to the left or to the right, but not go up or down at all. So let's say I move to the right 5, but then I don't move up or down at all, so that means that the y-coordinate has to be 0. So go to the right 1, 2, 3, 4, 5, but not down or up at all. So I'll label that point E on the x-axis. And likewise on the y-axis, that means that I have to move up or down, but not left or right at all. So from the origin, don't go to the left or the right at all. So we'll have point 0. And then let's say I move down 1, 2, 3. And I'll call that point F. So don't move left or right, but then move down 3. And there's point F. So there's just kind of a brief crash course reminding you about what we're doing with the coordinate planes, plotting points, and then those coordinates. Let's start looking at some of the applications that we're going to be doing with this, because the second part of the learning target from yesterday was to be able to kind of make connections between tables and graphs. Okay, so let's look at the variables that are being defined here. We're saying that the x variable is the number of tires in a stack, and the y variable is the height of the stack, maybe in inches or something. So if we wanted to say we're talking about the height of the stack in inches. Okay. And so if this is x and this is y, then we can create our different ordered pairs by just saying that when x is 1, when I've got 1 tire, the height of the stack is 8. When x is 2, when we have 2 tires, the height of the stack is 16. When x is 3, when we have 3 tires, the height of the stack is 24. Hopefully that makes sense. When x is 4, if I have 4 tires, the height of the stack is 32. Yep, this all makes sense to me. Okay. So now we just want to plot those ordered pairs, and notice that they've already labeled the axes for us. Okay, they're only giving us the first quadrant, because that makes sense, because we're only dealing with positive values of both numbers of tires and the height of the stack. So we only see the first quadrant, and essentially this is the y-axis, this is the x-axis, this is the origin right there. This is the value when x is equal to 0, and then this is when y is equal to 0. They've already labeled these for me as this should be number of tires and this should be the height of the tires, or height of the stack, but I want to put down the appropriate numbers here, okay? So, excuse me. So obviously the number of tires, it makes sense just to go by 0 tires, 1 tire, 2 tires, 3 tires, 4 tires, and 5 tires. Okay, when we look at the height of the stack, it's not typical that we count by 8s. So I'm not going to count by 8s here just because for me it doesn't make sense. What I'm going to do then is pick something that does make sense. I've got basically 4 sections of the y-axis, and I've got to go from 0, if we've got a height of 0, up to 32. I could go by 8s, but it doesn't really make sense for me to go by 8s. So I'm going to go by 10s. I think it sort of makes sense a little bit to go by a round number like 5s or 10s, or even 2s is okay, but here I'm going to go by 10s, and then that means that I might have to estimate a little bit where my points are going to be. So I'm going to plot the first ordered pair 1, 8. So when I've got 1 tire, 8's going to be a little bit less than 10, somewhere around there for the height of the stack. When I've got 2 tires, okay, I'm going to estimate 16. Halfway between 10 and 20 would be 15, so I'm going to go a little bit more than halfway. And then when I've got 3 tires, the height of the stack would be 24. Halfway in between 20 and 30 would be 25, so I'm going to go a little bit under halfway there. And then when I've got 4 tires, we've got 32, so that should be a little bit more than above 30. And we can see the progression of those points as we are steadily increasing the height as we increase the number of tires. Okay. So if this pattern continued, what would you notice the height of the stack of 10 tires would be? Well, I could probably start making my list and say, if I've got 5 tires, that should be a height of 40, right? Just kind of keep adding 8. And I've got 6 tires, that would be 48. And if I've got 7 tires, that would be, it looks like it's going to be another 8, should be 56. And if I've got 8 tires, that would be, another 8 would be 64. And then finally, if I've got 9 tires, that should be another 8, which is 72. And then 10 tires, okay, that makes sense. I should have a stack of 80 for 10 tires, and we should have a stack of a height of 80 inches or whatever. So if I've got 10 tires, we're expecting it to be 80 inches tall. And some of you guys obviously might have been able to see that pattern before looking at all of those ones in between. But let's take a look at what happens if I've got 100 tires. If we need to, we could say, let's look at if we've got 100 tires, okay, then obviously it looks like I just keep on multiplying by 8, so that should be 800 inches. But let's think about if we wanted to convert that to a different value. Remember back in chapter 2, we talked about ratios and conversions. Instead of talking about inches, it's kind of outside of what I know to work with inches. Let's say we wanted to talk about it in feet. The conversion factor from inches to feet is that there are 12 inches in every foot. So I'm going to convert 800 inches into feet and see how many feet tall this stack of tires would be. So remember that diagonal from inches, I want to put the part of the conversion that deals with inches, so that there are 12 inches in 1 foot. And then because we have this relationship going on, that should be a division. So basically that's going to be 800 divided by 12. And that's going to have to be a rounded value. It looks like we get 66.7 feet of tires. That's pretty tall. I don't know if we'd really want to make a stack of tires that big. Okay. And the final question, this kind of leads us into something we're going to be doing later in the chapter, but it says, can you think of a mathematical rule that relates the height of the stack, and remember the height of the stack was the y value, to the number of tires, and remember the number of tires was the x value. So can you think of a rule that I can make so that I can always figure out, if I know how many tires there are, I can figure out the height of the stack, or vice versa. So remember that we kind of just talked about that every time we have an x value, if I wanted to figure out how tall it is in inches, then we just multiplied by 8. Same thing here, 100 tires, figure out how tall it is in inches, then we just multiplied by 8. So it looks like if I want to figure out how high it is, then that's always going to be equal to 8 times the number of tires. And that's what we mean by a mathematical rule. If I know how many tires, I can figure out how tall it is. If I know how tall it is, I can figure out how many tires there are. Okay? So we can say that the height, if I want to do it sort of in words, of the stack was always equal to 8 times the number of tires. And then just with the variables, that's why we get y is equal to 8 times x. And there's our mathematical rule. All right, thanks for watching. I'll see you in class where we'll be practicing coordinate planes and tables and charts. Thank you.